Hi class! Welcome again dito sa klase natin sa Mechanics of Deformable Bodies, Mech 314. So today, we will discuss one of the most important topic dito sa subject natin. So it is under Unit 4, Shear and Moment in Beams. So before we start, let's have first our overview. So this unit deals with constructing the equation and diagrams for shear and moments in structurally determinate beams. Our learning objective here is first, construct the shear and moment diagram for structurally determinate beams. Second is write the shear and moment equation for every segment of the beam. So class, this topic is important to us civil engineers since we always encounter beams in our field. Sa Tagalog class, ang tawag natin dyan ay biga. So let's introduce what is beam. So beam is a structural member subjected to transverse loads. So ano na nga yung ibig sabihin pag sinabi nating transverse load? So class, yun yung load that are applied perpendicular to the planar surface of the beam. So in construction, beam are commonly used to support the slab. So itong beam na to is meron siyang different types. So una na dyan, we have a simply supported beam. So a simply supported beam is supported by a hinge reaction at one end and a roller support at the other, but it is not completely restrained. So, another example or another type of beam is yung tinatawag natin na cantilever beam. So, this beam is supported at one end only with a suitable restraint to prevent rotation. So, another type ng beam is yung overhanging beam. So, this beam is supported by a hinge and a roller reaction with either or both ends extending beyond the support. So, ito class, halos kagaya lang siya ng simple supported beam. So, meron lang siyang isang side na pwedeng isa or dalawa na naka-overhang. So, itong three types ng beam na to is under the statically determinate beams. So, ibig sabihin, we can easily find the value of the reaction and the moment doon sa ating fixed end by using equations of equilibrium. So, ulitin ko lang, the reactions of the given beams above can be simply obtained by applying equations of static equilibrium. Hence, they are called statically determinate beam. Other methods of beam supports have at least one or more reactive element that is absolutely necessary are referred to as statically indeterminate. The presence of excess supports requires the use of additional equations obtained from the geometry of elastic deformation of the beams. So, ito class yung sample ng mga statically indeterminate beams. So, first, we have a prop beam wherein yung one end niya is roller and yung one end is fixed end. The other example is yung fixed-ended or restrained beam. So, both sides naman niya or both ends is in fixed connection, and lastly is yung tinatawag natin na continuous beam. So, series na siya ng beam that is supported sa ends nila and sa intermediate points, so merong mga roller. So, dito sa statically indeterminate beams wherein hindi na natin kaya masolve yung mga reactive forces and moment using the static of equilibrium alone, so kailangan na natin dito yung additional equations na manggagaling sa relationship ng deflection, which is yun naman yung magiging topic pagdating sa theory of structures. So, next naman, ano-ano ba yung mga types of load o possible loadings na pwedeng mag-act doon sa ating beams? So, una, we have the concentrated load. So concentrated load acts over so small a distance that it can be assumed to act at a point. Or pwede natin sabihin na this load acts on the point of the beam. So for example, ito yung beam natin. So ito naman yung ating concentrated load. So siya ay point load. So for example, may tao na tumungtong dyan class. Yung weight niya, yung load niya is acting like a concentrated load. So andito lang siya. Dito lang siya nag-act. Okay? So ano pa ba yung ibang possible loadings? So we have yung tinatawag na distributed loads, wherein it acts over a considerable length of the beam. Ito ay pwedeng uniformly distributed loads or linearly varying distributed loads. So, dito sa figure natin, yung dalawang A, ito, is a concentrated loads. Yung B-1 naman is yun yung tinatawag natin na uniformly distributed loads. And yung B-2, yun naman yung itsura ng linearly varying distributed loads or uniformly varying loads. Yung B-3 naman natin dito is varying loads. Meron din trapezoidal loads wherein it is a combination of uniformly distributed and uniformly varying. So, example ng uniformly distributed loads, pwedeng itong beam mismo dahil yung weight niya is uniformly distributed doon sa buong length ng ating beam. So, dito class, medyo complicated na yung mga possible loadings pag nag-analyze tayo ng beams. So, unlike in our previous topics na madaling ma-analyze yung load, so dahil doon, madali pa natin nakukuha yung mga internal forces or internal moments and yung mga stresses. So, ngayon na it's complicated na siya, mahirap nang malaman kung saan portion ng beam nag-i-exist yung mga maximum stresses. So, take note ha, ang goal natin dito is to determine the maximum stresses na nade-develop dito sa ating materials para mapaghandaan natin na hindi niya ma-exceed yung allowable stress ng ating materials. So, kailangan i-locate natin yung maximum stresses. So, again class, we need to locate the maximum stresses so that it won't exceed the allowable capacity of our materials. So, since complicated na yung loading diagram, meron tayong tinatawag na shear and moment diagram. So, in strength of materials, the determination of the relations between the stresses and deformation caused by any applied loads in one of the basic problems, the study of these loads is complicated by the fact that the loading effects may vary from section to section of the beam. So, these loading effects take the form of a shearing force and a bending moment, usually referred to as shear and moment. So, balik tayo sa shear and moment diagram na sinabi natin kanina. So, itong shear and moment diagram is ginagamit siya sa pag-analyze ng beam para madaling ma-visualize kung saan portion ng beam at kung ano ang maximum forces o moment ang nade-develop dun sa ating beam. So, define natin siya. So, shear and moment diagrams are merely the graphical visualization of the shear and moment equations plotted on shear and moment x-axis as determined before or simply by graphical representation of shear and moment throughout the span of the beam. So, before we proceed, kung paano ginagawa yung shear and moment diagram na yan, aralin muna natin yung mga sign conventions. So, dito, kailangan sundin natin yung tamang positive direction ng mga shear and moment para tama din yung magiging analysis natin. So, we assume the following to be positive. Shear forces that tend to rotate a beam element clockwise so that it is assumed to be positive. So, ano ba yung itsura niya? So, let's say, we have a beam and we cut it. Take note, for us to show the shear and moment, yung internal shear and moment is kailangan ika-cut natin yung section. So, maghihiwalay yung left segment sa right segment. So, considering the left segment, para maging positive shear siya, sabi, dapat it tends to rotate the beam element clockwise. So, para maging clockwise ang rotation, so dapat sa left segment, the shear must be acting downward. So, parang ang ikot niya ay clockwise. On the other hand, for our right segment, in order that the shear forces to be clockwise, the internal shear must be directed upward para clockwise yung direction niya. So, upward shear on the right segment means positive shear. So, next naman is dito sa sign convention natin sa moments. Bending moments that tend to bend a beam element concave upward is considered positive. Or para mas madaling tandaan, kapag nakasmile or happy yung beam, that moment that caused the beam to smile is considered positive. So, ganito yung magiging itsura niya. So, kagaya kanina, we cut a beam into two segments, left and right. So, for us to consider it positive, unahin natin itong nasa left segment. So, paano ba siya magiging concave upward? Paano ba siyang ngingiti? So, dapat, ang moment mo ay counterclockwise. Para ma-bend niya itong beam natin na blue na maging kagaya nitong kulay yellow. So, next naman, dun sa ating right segment, para ma-bend niya itong beam natin, dapat ang moment niya ay clockwise. Para ma-bend niya itong beam natin na kulay blue, maging ganito yung itsura niya sa kulay yellow. So, kailangan nyo lang tandaan, pagdating sa moment, counterclockwise sa left, para maging positive moment siya. And then, clockwise moment naman sa right para maging positive moment siya. So, kung malinaw na tayo dito sa sign convention, dito naman tayo sa shear and moment diagram na. So, in creating shear and moment diagram, there are two possible ways. First, we can use the method of section. Next naman is yung method of area. So, each method is may kanya-kanyang advantages and disadvantages. So, let us define first ano yung method of section. So, shear, which is capital letter B, and moment, which is capital letter M, as function of X for each segment of the beam between a change in loading point or discontinuity in loading. O sa madaling salita, ang method of section, ang ginagawa nito ay nag-create siya na equation ng shear and then moment with respect sa x. So dito, equation ang ginagamit. Ni-utilize dito yung equations of equilibrium para ma-define natin correctly yung equation ng shear and moment as a function of x. On the other hand, we have the method of area that expresses the change in shear equals the area under the loading diagram and change in moment equals the area under the shear diagrams. So, dito, ginagamit natin yung area ng loading diagram or area ng diagram para ma-solve yung equivalent shear and yung equivalent moment niya. So, sa dalawa na to, mas madaling gamitin yung method of area. Kaya nga lang, ang disadvantage niya ay may time na mahirap ma-solve yung equivalent shear and moment. So, pag ganun, pwede natin ipasok or gamitin itong ating method of section. So, ngayon, mahirap pa siya ma-imagine. Pero pag nag-solve na tayo ng mga problems, mas makikita nyo. And then, Bago lang tayo pumunta dun sa mga steps para sa paggawa ng method of section, kailangan i-discuss lang din muna natin ito. So, consider a simply supported beam located with a concentrated load P as shown in figure A. So, the beam is held in equilibrium by the reaction R1 and R2. Neglecting the weight of the beam, assume that a cutting plane AA is to pass through along the beam at a distance x from R1. The free-body diagram of the left segment shows that the externally applied load is R1 to maintain equilibrium in this segment of the beam. The fibers in the exploratory section must supply the resisting forces necessary to satisfy equations of static equilibrium. The condition summation of x is equal to 0 is automatically satisfied since there is no horizontal load acting. To satisfy naman yung summation of forces, summation of forces vertical is equal to 0. So the vertical unbalance caused by R1 requires the fibers in section AA to create a resisting forces, shown as VR, and is called the resisting shearing force. As shown in the FBD, VR is numerically equal to R1. If there is an additional load applied between R1 and section AA, the net vertical unbalance would be found from the summation of their vertical components. This is equal but oppositely directed to the resisting shearing force. The net vertical unbalance is defined as the shearing force in the beam and is denoted by capital letter V. So, medyo mahaba yun, pero sa madaling salita, sabi lang doon, walang horizontal force na ikinoconsider. Kasi, there is no horizontal load acting sa beam natin. And, gagamit tayo ng FBD, cut natin yung beam into segment, and para ma-solve ang shear is magsa-summation of forces vertical equals to 0 lang tayo sa bawat segment. So, from there, we can solve the shear. So, next naman is sa bending. Ito pa pala. So, this definition of shearing force, also called as vertical shear or just shear, is expressed as V is equal to summation of forces vertical. Ito, left lang to. Okay. So, summation of forces vertical lang siya pagdating sa ating shear. So, next naman is dito na tayo sa moment. So, from the FBD of the left segment, the summation of moments must also balance. R1 and BR are equal, thereby producing a couple M, which is equal to R1X. This moment tends to bend the beam, hence is referred to as a bending moment. So the fibers in the exploratory section must create a numerically equal resisting moment, MR, acting as shown. In most beams, the free-body diagram carries numbers of loads. Hence, a more complete definition of bending moment is necessary. Bending moment is defined as the summation of moments about the centroidal axis of any selected section of all the loads acting either to the left or to the right of the section. So, pagdating sa moment, ang kailangan natin gawin is of course, summation ng moment, pwede dun sa left, summation ng moment, and pwede din naman dun sa right. So, dito sa bending naman, so sabi lang dun, yung bending moment natin is makukuha natin kapag naggawa tayo ng free body diagram. And then, magkakat lang din tayo ng ating beam into segment. So, pwede i-consider yung left, pwede i-consider yung right segment. Tapos, yung moment natin is equal dun sa mga forces multiplied by distance from our reference point. So, saan yung magiging reference point natin? So, pwedeng dun sa ating left side or pwede dun sa right side. So, ano ba yung procedure para magawa natin yung method of section? So first is to compute the support reaction. Under sa discussion natin, ang mga i-analyze lang natin dito ay yung mga statically determinate beams, wherein the support reactions ay madaling isolve sa pamamagitan lang ng equations of equilibrium. Next is to divide the beam into segments so that the loading in each segment is continuous. So mamaya, papakita natin paano magde-divide ng segments ng ating beam. Next is to introduce a cutting plane with the segment located at x distance from the left end of the beam that cuts the beam into two parts. So every segment na nagawa natin sa procedure number 2, so each segment, mag-i-introduce tayo ng cutting plane. And that cutting plane is ilolocate natin at x distance from the left end of the beam para makapag-generate tayo ng equations ng shear and moment. And number 4, choose a section to consider, whichever is more convenient. So dahil nag-cut tayo ng section, we can have a left segment or right segment. So whichever doon ang mas madali yung pag-create ng equation. At the cut section, show shear and moment acting in their positive direction. So yun yung diniscuss natin kanina na sign convention, kung paano nagiging positive yung shear and moment sa ating beam. And then next, determine the expressions for B, which is shear, and M, which is moment, as a function of x using equations of equilibrium. So once na na-set up na natin yung correct direction ng shear and moment, nakapag-consider na tayo ng segment na gusto natin i-consider, so ngayon, ready na tayong gumawa ng equations. And then lastly, since may equations na tayo, we can now plot the expression for shear and moment for the segment. It is visually desirable to draw the shear diagram below the free body diagram of the entire beam, and then draw the moment diagram below the shear diagram. So itong mga steps na to, medyo mahaba. So, medyo mahaba yung mga steps niya, pero mamaya, papakita na lang natin step by step kung paano natin nakikreate yung shear and moment diagram using method of section. So, next naman is, dito tayo sa method of area. Ano ba yung procedure niya? Paano ba ito ginagawa? So, una na dyan is, again, compute the support reactions of the beam. Next is to draw the shear diagram using the area under loading diagram. Note that shear diagram is always 1 degree higher than the loading diagram. Yung area ng loading diagram, yun yung gagamitin natin para malaman yung shear value. Next is to draw the moment diagram using the area under the shear. Note that moment diagram is always 1 degree higher than the shear diagram. Pag nagawa na natin yung shear diagram using the area of shear diagram, so maidodrawing na natin yung moment diagram natin. Take note class, palaging 1 degree higher sila sa sinusundan nila. So, that is the degree of the slope. So, discuss lang natin para ma-visualize nyo kung ano ba yung itsura ng mga degrees. So, considering yung type ng ating mga load. So, dito class, meron tayong, dito sa type of load natin, we have a point load, uniformly distributed, linearly varying load, and a varying load. So, ano ba yung mga degree nung bawat type na to with regards sa load nga niya, sa shear, and sa moment. So, pagka sa point load, ibig sabihin lang class, wala siyang degree pagdating sa load. Ngayon, sabi nga natin, 1 degree higher siya. So, from load, dilipat tayo sa shear diagram. Kailangan 1 degree higher siya. So, from wala, magkakaroon tayo na 0 degrees. So, para ma-generate naman natin yung moment diagram, so from 0 degrees ng ating shear, plus 1 degree lang tayo. So, meron tayong 1 degree sa moment. Okay? So, ano ba yung itsura ng 0 degree? So, dito makikita nyo, class, yung 0 degree, ang katapat niyang type ng load is uniformly distributed. So, ibig sabihin lang, class, kapag i-drawing natin yung shear diagram ng ating point load, ang itsura ng kanyang shear ay ganito, uniformly distributed. Kapag i-drawing naman natin yung moment ng ating point load, di ba 1 degree siya? Ito, 1 degree. So, ganito ang magiging itsura niya. Linearly varying load. Okay? So, ang given naman, class, is ito. Ang given sa atin na type of load is uniformly distributed. So, sa load pa lang, 0 degree na siya. Horizontal. Okay? So, pagdating sa shear, ang magiging itsura na kaagad ng shear natin is linearly varying load. Okay? So, pagdating naman ng moment, dahil plus 1 degree siya ulit, so magiging 2 degrees. So, pagka 2 degrees na siya, ganito na siya, class, curve. Magiging curve na yung itsura ng kanyang moment. Ngayon, kung ang given naman sa atin na type of load is linearly varying load, 1 degree na siya kaagad pagdating sa ating load. Pag dinrawing natin siya sa shear, so 2 degrees. So, ano itsura kapag nag-shear tayo ng linearly varying? Curve na siya. Okay? So, dito naman, pag dinrawing natin yung moment nito, nung linearly varying, so 3 degrees. So, saan yun, ano yung magiging itsura nun? So, ang itsura pa rin nun is curve. So, to generalize, class, so, any degree higher than 1, okay? So, ang itsura niya na ay curve. So, ganun lang. Kailangan matandaan yun para pag nagdo-drawing tayo sa shear and moment diagram using method of area, alam natin kung ano yung magiging itsura. Okay. So, next, summarize muna natin to. Sabi natin kanina, pag first degree siya, it is a line that is either a line upward to the right or line upward to the left. So, ngayong class, balik lang tayo ng konti sa analytic geometry. Paano ba nako-consider kung negative slope yung line o positive slope ng line? So, para ma-consider siya na positive slope, dapat ang direction niya is ganyan. Upward to the right, so positive siya. So, ganyan dapat ang orientation ng ating line. Para naman masabi natin na negative yung slope, upward to left or downward to the right, under ganyan ang orientation. So, next naman, sabi natin, di ba, sa second and third degree, and so on, na degree, which is, yun nga, greater than the first degree, yung drawing na niya class A ay curve. So, paano natin malalaman kung yung curve na yun ay increasing yung slope o decreasing slope? So, dito kasi, iisa lang yung slope. Kasi line lang siya. So, dyan, iisa lang yung slope kasi line lang siya. So, madaling malaman. Pero ito, positive yung isa naman negative. So, dito pag curve, na it's either increasing slope or decreasing slope. So, ito, importante ito, class. At sana matandaan nyo, kasi ito yung gagamitin natin na basis sa pagdodrawing natin na shear and moment diagram gamit yung method of area. Okay? So, para masabi na increasing yung slope kapag under tayo ng second degree, so, ang curve dapat natin is concave upward. So, bakit ito naging increasing? Simple lang yung drawing. So, simple lang yun, class. So, mag-drawing tayo ng tangent line dyan. Okay? Yung slope dyan, yung ganyang slope is a negative slope. From negative, so, sa right slide, and slope na niya is ganito. Okay? So, ibig sabihin ay positive slope. So, from negative to positive. So, therefore, nagkaroon tayo ng increasing slope. So, increasing yung ating slope. So, for this decreasing downward naman siya, so from positive slope to negative slope. Decreasing ang slope value. So, ganun na din sa third degree. So, increasing concave upward and then decreasing concave downward. So, ito mahalaga lang ito class. Okay? Doon naman tayo sa discontinuity. So, the discontinuities in the shear diagram are joined by vertical lines drawn up or down to represent the abrupt change in shear caused by upward or downward concentrated loads. Mamaya class, sa example, doon nyo makikita kung ano yung sinasabi dito na discontinuity sa method of area. A final point to be observed in the moment diagram is the highest point and the lowest point always correspond to the point of zero shear. Shear and moment at the change of load points can be computed by substituting approximate values of x in the foregoing shear and moment equations. Computation of numerical values of shear and moment can be made simpler and more direct by applying the fundamental definition of shear and moment to specific sections.